I'm gonna be presenting to you, introducing something new called Itheno. Not new for some of you, I guess, but maybe new for most of us. And my purpose and my aim in introducing that tool is to leverage Echidna, which was already presented by Andre earlier, like 4 weeks ago, a month ago from now. And it was really beneficial because I believe actually this is how we're going to be doing our tests in the future. So we better be paying attention to that. So that's just going to recap on Echidna, just to remember. This is just a simple example of what it is. Can you guys see? Can you guys see actually what I'm presenting here? Or do I need to increase the font? Okay, I guess. Okay, fine. Let's go. Okay, so the point of Echidna is to test what we call invariants. So just a recap, if you don't know Echidna already, I'm not actually going through explaining Echidna, but I'm just recapping. So the point of Echidna is to test invariants. You know, things that you are sure that's actually kind of a constant throughout the test of your contract. And if it changed, it means that there's something that has gone wrong. So in that sense, like we have this example for instance, like this is a simple storage, and the point of this simple storage, for example, is to have a variable called store data, and that variable is always 89, and it shouldn't change. So in that sense, okay, that's basically my test. I will just make sure that no matter what is going on in this contracts in the blockchain, this variable should be always 89. So that's just basic what Echidna does. You just come up with an invariant and you test and to make sure that this invariant is basically non-variable. It doesn't change. That's why it's called invariant. So, shouldn't be showing that. Okay. So that's basically what it is. But what I'm gonna be looking forward for the rest of this presentation is, what if we actually need to have some sort of like an ecosystem while we are doing that Echidna test? In simple terms, what if I'm not actually checking a storage in that simple storage? What we would not actually checking the variable in that contract, in that simple storage contract, and we need to check a variable in another token, like in an external token, an external asset. And we only have we need to introduce that token address in our Echidna test. So this is actually basically what I'm going to be going through. And you can generalize from this point to do anything you like, to have like a whole DeFi ecosystem introduced to your Echidna test. So the tool that's going to be helping us to do that is called Itheno. So that's basically what it is. Should be having like want to send you like GitHub link, but I'm afraid the recording is gonna go away. So I will send you the link to the repository of that tool after we finish this presentation. So what Itheno is, it is a project done by Critic. Critic is also the team that done Echidna for us. So they did both, and actually they made it so that they work together. So it is not something that's I'm introducing. Like I'm trying hard to make it work with Echidna. It is already set up to work quite well with it. So what Itheno is doing is it kind of creates to you the snapshot of the blockchain that you are going to that you're going to start from it and do the testing. So you can think of it like we all know, like when you want to do some testing and you want to fork the mainnet, for example, you want to fork some other blockchain and do the testing from that point. And it's kind of a snapshot. You're taking a peek of the blockchain, of the contracts, the deployed contracts, of the current state of it, and you want to do the test based on this state. So this is also what Ethereum does for you. It picks up like kind of a snapshot, contracts, addresses with transactions, everything, and it saves to you and makes Echidna actually do the testing from that point. So, and by the way, it works with Truffle. I was trying to make it work with, when I was beginning to work with it, I was actually trying to work with Hardhead, but it didn't go quite well. It won't tell you no. It actually would work with Hardhead, but you're gonna face lots of trouble. So you typically preferably don't try to do that. I don't prefer Truffle, to be honest, but I had to work with Truffle in order to be able to introduce this tool. So I'll just present you a demo of how it is like actually. So in order to get to work with Itheno, first I will install it. And since I'm already, to be honest, I like to work more with Docker. There's other ways to install it, basically with Python, pip. But for me, I prefer Docker. So this is the way I'm gonna be working with it. So I'll just take that command as it is. This is the name of the image. And this is just sharing the folders between the Docker container and my local PC, kind of. And this is the important part, which is sharing the ports. Itheno Works underlying like the blockchain is Ganache, and we know like Ganache default port she listens to is 8545. And this is just port forwarding between the container and my local PC. So anybody have any trouble doing that with Docker? Kind of. So we can do it with Python anyway, and can install it in your local machine, and you don't have to do this. But anyway, it's more simpler for me to do it with Docker. So I'm gonna start a container here. Okay, then you'll, and this is actually how it's gonna be working now. Now I'm gonna write a command in order to capture basically the snapshots, start capturing what is going on in the blockchain. This is the main purpose of Ethereum. It's not about, doesn't do the test itself, but it helps you do the test. So, oh, sorry. So I'm gonna write this command. It's gonna capture the transactions going on the underlying Ganache blockchain, and it's gonna throw it into this file. And I'm calling it Init.json because it's gonna be kind of the initialization. So I'm gonna delete this file from here so that you see it actually gets reproduced, so that I'm not deceiving you or something. So here you are. So it's gonna start for you a blockchain already, and you can go here. It created the init. Oh, sorry, I shouldn't be doing this. Something here. Okay. The thing is, because I'm using Docker, first I will need to navigate through the workspace which I'm working on, and then gonna run command again. So now I'm gonna see the init.json here, just got created. First thing, you can see the accounts that are already on the blockchain. So there's something here that is a little bit deceiving, which is this. It says that it's listens to 8546. I guess this is a problem in the container itself. It actually listens at 8545. I'm sure of that because I know from networking that it was listening on that port. But that's maybe like need to be fixed by them. So anyway, this is this is how it begins. Like just accounts, no transactions right now. Didn't create any contract. I didn't do anything. So how do you actually start the transactions? It's very simple. You do the transactions by just calling tests, and whenever whatever the test is doing, it dumps these transactions into that file. So you actually report all what is going on into that Init.json here. So let's take a look at how it's gone. So I would be doing this with a simple storage smart contract, which is like just a boilerplate from Truffle itself. It's just a contract that have a variable, and that variable we can set and we can actually view. So that's it. I will just create the contract, deploy the contract into the blockchain, and then I can set the value. But right now I would just want to show you when I create the contract, what's going to be going on and run that test. So going to be running here. I'm going to run it the wrong way, basically. But I'm going to ask you what is wrong in that. So I'm going to run it like that, basically. So it showed you the test is run and everything is cool, but you don't see any transactions going on here. So what do you assume is going to be the problem? And I just run the test like that, just for interactivity. Exactly. Yeah, exactly. I'm just running that test onto the Truffle environment, to the Truffle blockchain or whatever. And this, this ganache network, basically, the RPC here is didn't listen to anything. It's just isolated, didn't get to listen to what Truffle is doing. So in order to do that, you have to make sure in your Truffle config, you have a network, and that network is connected to the port, the 8545. And that 8545 is wired into your local machine. And because I'm running it in a container, this is why I made sure when I'm running the container, I'm forwarding from 8545 to 8545 inside the container. So this is how it's going to go. Like I'm going to run Truffle into that network, and there will be like a port forwarding between the local machine and the container, and it's going to reach finally this container. Yeah, it says here 8546, but this is deceiving, as I told you. So I'm going to run the test again, but this time I'm going to make sure it's actually running on the right network. So, and I'm going to have a peek here. So you see, now the transactions are going on. So the transaction that's gone on, it's nothing complicated. It's just contract creation, basically. So I just created a new contract. So in that sense, if I go to the Init.json, you see here, contract created. So it saves the state of that contract here. So that's basically what it is. So any question to this point? Anything I need to elaborate? Okay, I think everything is simple right now. Gonna get to the complicated parts after that. Okay. So I just want to make you see the changes by yourself. Now when I got make a new transaction here, I'm gonna add that transaction to the test and I'm gonna run the test again. So we can look at the Init.json right here right now. So I'm gonna be expecting, because I'm running another test, on a new contract will be created. And that contract, there is also a function call after that, which is the set, the storage. So you have here, the first contract is created in that address, and the second contract is created on another new address. And the transactions that I've done is executed on the new contract, because the old contract, there was no transaction already. So that's basically what Itheno is doing. It of course it does more than that, and you can go to the documentation in their GitHub. But for us, because we need to do that working with Echidna, this is actually what I'm gonna be concerned about for now. So now let's get to the example that we found to work with. I think there's no problem here. Okay. Okay, so that's basically what I'm gonna be doing an Echidna test on. And that's just a token. And that token is having an underlying asset. And people can deposit to that asset to the token, and they're gonna get they're gonna be the token is gonna mint new tokens for it. So this contract is gonna mint new tokens for it, basically. So I'm just transfer an asset to this address, and I'm gonna receive the same amount of that token into my address. And after that, I can withdraw. So I can withdraw amount, and that is gonna burn that amount, and I will withdraw the asset. There is something wrong. That's why I call it a bad token. There is something wrong here, and I guess it's very obvious. And I want you to get it, spot this mistake, but not mistake, but I mean, like, I want to spot this flaw. It's not something in the security. I don't care about your interagency or other stuff, but I'm just care something about the numbers itself, and it's very obvious, I guess. So what do you think is wrong here between the deposit and the withdrawal? So I'm gonna give 1 minute because it's very obvious. Yeah, of course. So you would need to keep the find it. Yeah, exactly. This is a problem. Like when you see user deposits, for example, if I deposit one of that asset, I would get a mint of one of that token. And if I want to withdraw half of it, I will withdraw more, 1% more of that. The thing is, there is an imbalance here. There's an imbalance, and that imbalance actually will end up having, you'll end up having some tokens without an underlying asset. So basically, you're kind of over withdrawing what you're already having into your asset. So I know it might not be a problem with most tokens, because most tokens have this kind of thing actually going on, but they have some kind of other interesting stuff to do, like to incentivize people. But this is imbalance actually is very exposed, and Echidna should discover it for us. So it's I know it's very subtle, like it's just 1%, but Echidna somehow will discover it also. So this is what I'm gonna do here. I'm gonna write a test for that Echidna. Sorry, for that token. So let's take a peek here. So what do you think like the test is gonna be? Like, just give me an idea. I told you like the problem is I'm over withdrawing amount of assets compared to the token that I'm already possessing. So what is the invariant here basically that you think can be? It's basically a point if Echidna is hitting, it returns false rather than true, and the test is failing, and it shows you what is the problem. So I give you 2 minutes just to give me the idea, not writing a code, just to give me the idea of the invariant. Yeah, in assertion I don't have to return goal, like make sure that mount. So that's an idea, but I thought about it in a property test, as a property test, and it still spotted it. Like there can be different approaches, of course, but okay. So do you need to think about it, or do I just go straight forward for the test itself? Upload it where, and then I just can upload it. It's recorded by me. Okay. 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 So it would basically the idea would revolve around this. Like if the token still possesses a total supply, there's a total supply, but the underlying asset is zero. You don't have an underlying asset. So it means something is wrong, right? Because if you have no underlying asset, you shouldn't be having total supply, because in that sense, people will be having tokens and they can't withdraw anything because there is no underlying asset. So that is basically the test that I'll be going through. So it's already pre-prepared and oh, sorry. Okay, so it's basically the check. I'm gonna be Echidna would be doing its magic. We'll be doing fuzzing, what's called fuzzing. It's doing lots of calling withdrawal and deposit and all that stuff. And then it's gonna call this function. And when it calls this function, it's gonna check what is the underlying asset, what is the underlying asset of this contract, and compare it to the total supply. If there is a non-zero total supply and the asset balance is zero, then that's something wrong here, and I'm gonna make the test fail. And it's gonna show me the sequence of faults that actually led to this failure. So that's basically what's gonna be happening here. Let me okay. I already run Echidna, and it's preferably to run it using a Rendesk. So don't think I need to show you that. So it's not in our scope. Here's the project, and I will need to make sure that before I run it. Okay. Okay, now I'm gonna run like in test and just make sure that the test is already there. So this is a test I'm gonna be running against. Remember contract. So it's tester. Okay. Sorry for that. I just went over the important thing, actually. Almost forgot myself. Okay, so what we need here actually is, you can see that. I'm sorry, I overlooked this. uh, so the point is, I want to run the test of Echidna, but there is an underlying asset. And in a way, we can't actually get the underlying asset without Itheno, basically. So the thing is, I'm gonna run tests in order to deploy Itheno and introduce it here. I'm gonna do that with you. So I was able to come up with this address and put it in Echidna, and Echidna will pick up the snapshot that we just created with Itheno that I showed you how to create it. Echidna will pick up that snapshot, and when it sees that address, it knows, okay, that is the address of the underlying asset. And from this point on, it is gonna do the tests. So this is like the initialization point in which it's gonna go through. So first thing, I'm gonna go back to Itheno, and I'm gonna create the initialization, this Init.json file, but this time for the asset itself. So it's gonna be just a simple token. I'm gonna ditch this. It's gonna be just a simple token here. This is the asset. It just we don't need this function, but it just have a function for, minting for the owner, and it's gonna go through it so that we can distribute that token. So right now, I'm gonna do that same thing, but for the asset itself. So it's gonna create a new init.json, and I can fill that initialization with whatever I want. I'm gonna go here. Rather than running a test to simple storage, I'm gonna run this test. This test is gonna initialize the token to me. So first thing, I will need to deploy the asset, the token that I just showed you. And second thing, I need to approve it. I need to approve it to transfer my tokens. And that's basically because if we go back to the bad token, you're gonna see in order to deposit the asset, I have to transfer the amount of the asset to the token. So I had to approve it first to be able to do that transfer to me. So in that test, I do that call already. And there's something interesting here, which is the Echidna address. This is basically the address of the contract that gets deployed by Echidna. It is the address of the tester here. So that's basically it. You can find that from documentation, that address. And actually you can find that you can change it, of course. Like it's just not, it's not something that you can't play with. You can change that address and do whatever you like. But I got that address, and what I need is to approve that address to use my tokens. So I'm gonna run that test. Okay. Let me monitor here. So you can see, okay, where is the contract created? Yeah. So there's a contract creation, and there is a function called, which is the approval function. So that's what I'm expecting. This is a contract creation. This is a token, and this is the address of the token here. So I picked up this address and I put it here in the tester, basically. So because now, the blockchain doesn't start from scratch for Echidna. The blockchain starts from here. So now we have also the approve function call. Yeah, this is the approve function. So everything is fine. We can go ahead and call the Echidna based on that initialization file. So Okay, now I'm gonna move that here. Okay, so in order to wire that initialization file with Echidna, we have a config file. And that config file is containing what do we want to configure Echidna with. We can skip that, doesn't necessary now. This is the one we interesting about. So I'm telling Echidna, when you initialize yourself, I want you to read from that Init.json. I want you to start from here. So it's gonna start from this snapshot of the blockchain. Something else, I don't want that. Anyway, something else is the center. I want to tell Echidna who is able to call the content, all the methods of that contract while doing the tests. This is a default caller of Echidna, by the way. This is the default address of the caller. And this address is the address I'm interested in because this is the holder of the asset itself. This is the one who can actually do the deposit, to deposit the asset into the bed token. So I want this guy actually to be able to call. This guy is not important because it doesn't spawn any assets. So this is an important part to add here while doing the test. So how do I know the address of this guy? It's already here already. So this is all the call of everything. So you can wire everything together here. So that's actually what's cool about. So right now I can add the Init.json and the config file now. Let me check it here. Salami. This is the RAM desk, by the way, because as Stefan told us, like it's preferable if you're gonna call Echidna, you call it from the RAM. You can create a storage in the RAM disk, and you do all this fuzzing inside that part because the SSD is negatively affected by the way Echidna is doing its thing. So you better do your guys work. So right now I'm gonna so let's check the initialization here. Okay, I'm thinking. Okay. So at this point, I can start the fuzzing, and let's take a look what the game is going to be doing here. Tester. Tester is the name of the contract I'm going to be doing the tests on. And here we need to add the configuration file. So this is the config.yaml. I hope it runs. Okay, something really interesting about this. In most cases, while I'm running this test, I find an error. I find a failure, which is actually the expected result. But at 2 occasions, I ended up with a success. And that's basically because the random seed, gives us like sometimes you do the call, sometimes you fail, sometimes you don't. So that's why it's a little bit tricky, like really. So right now it failed, and we're gonna look at the poll sequence that failed. And as expected, actually, it does 2 deposits and it did 1 withdrawal. And somehow when it did that, it ended up with a condition that we actually default on, which is you have no asset balance while you still have some token supply. So it's just a normal deposit and withdrawal. And this is what we expect, actually, some deposit and some withdrawal with certain numbers, and you end up actually having a problem. So that's what Echidna is showing to us. I had a test before also, just in case this test didn't make it. So yeah. Okay, so like, what do you think of what's going on here? Because next time maybe we need to do another test. So Is there anybody having a question this part? Well, I think also about that, and actually there's a conclusion that I come up with this. I'm kind of trying to come up to be closer to a kind of a state of the art. This is not a final thing yet, but a state of the art in order to do the test. My aim is to have a kind of an ecosystem embedded in a file like Mainnet.json, like that. This ecosystem can be like having Uniswap, using Kyber, using Aave, or whatever. And you have this like a DeFi ecosystem. And when you do, when you have like the contracts that you audit, we plug these contracts into that ecosystem and we do the testing. And you also have the coverage and you have everything. So it's gonna be cool. Like I couldn't reach that yet, but I think it's kind of doable. Maybe you can do that. And you actually have like, you can spot sequences that make failures that, we don't actually we might overlook at without this tool. So yeah, I think it's interesting, as I say, really. Can make a lot of complex scenarios. Yeah, I guess, yeah, I actually thought about it, but I didn't look into it. Like, I thought about it, like, maybe, like, this makes this Init.json actually fork from a mainnet. Right, that's what you mean, right? Yeah. Yeah, of course, like, it's gonna be cool, but, I didn't, to be honest, I didn't look in too much detail about this part, because I just wanted to make this presentation one day, at least, no. Okay. I was thinking because if we made a failure, maybe we need to make sure that actually it succeeds if we have a proper tokenomics. So maybe we'll make sure about this together. It can take 2 minutes, maybe. Like I'm just gonna change it. Yeah. So I'm just gonna change that bad token to the good token, which is already here. This one is very simple. You just deposit some amount, you can withdraw the same amount. Basically, this is the right thing. It's like a peg. So I'm gonna do the test on that rather than doing it. And you should expect to have success. So I'm just gonna hit the red disk with this change. Hello. My thumb is okay. So I'm sorry, it's not Suzuki. Okay, so right now I'm expecting to just go through the 50,000, fuzzing things, and there will be no failure supposedly. So it's gonna take some time. This, by the way, this is very simple. This is very simple repo, very simple like example. If we do that with a real repo with a DeFi ecosystem or whatever, gonna end up like having hours of testing, I guess. So it's not gonna be like quickly like this. Okay, so anybody have any question while this finishes? Because I guess it's gonna go through all the test cases. Yeah, it should succeed. It should succeed because there is no any trouble here. Like the amount you deposit is the amount you withdraw, so the economics is perfect, and I think it's gonna be problematic here. So I'm expecting it should succeed. Yeah. I guess that's actually what Andre took brought up here. like if you want to fork a real blockchain, you know, we will not do it with regularly because it's a test network anyway. We can do it, but I mean, like, there's no point. You can fork mainnet itself, like, you can just introduce the mainnet itself into this test. We didn't do it yet, but maybe it's possible. Actually, I think it's possible. Is that your question? Okay. Yeah, that's exactly what I'm talking about. I told you, like, get a net file, snapshots from a real blockchain, but I'm not sure about it, to be honest. But I think it's possible. It can be from Ranked, it can be from the mainnet, whatever. If it's possible from the mainnet, which is basically a fork. That's what you mean, right? I'm not sure, to be honest, how it's gonna be done, but maybe it is possible. If it is not, then we'll do it that way.